So with the changes so far in the library, I think we're in a pretty good shape in using the news API crate to build applications on top of, and I thought, why not use it to build a native GUI app in Rust? So I built one, and here is how the app looks like. So the app is named Headlines. You can scroll through the list of articles. It is also responsive and comes with built-in support for dark mode. You have the 3 buttons here. You can change the theme. You can refresh the list of articles, and the articles are fetched from the news API crate we built before, and there is the close button that quits the app. So this episode is a journey into the whole process that went into building Headlines, right from the wireframing of the app to planning the widgets we need, where and how we want to render the articles, and the implementation in code. If you feel that you need more context, you can watch the last 3 episodes. The links are in the description. So I started by collecting the data points we need to render the app. At minimum, we need the title of the article, the URL, and a description, which is a field I later added to the news API crate. Once I had the data model, I went ahead and created a rough wireframe of the app just to lay down my thoughts on paper and get an idea on where and how I want the articles to render within the app. So at the very top, you have the title bar. To the left, you have the name of the app or the logo, and to the right, you have 3 buttons. The first one will let you change the theme. The second one you can use to refresh the list of articles, and there is the close button which quits the app. Then we have the app header, which simply contains the top headlines label. Next, we'll have a scrollable container widget, which will contain a news card widget. And this is again a container widget. And it is the news card widget which will contain the title of the article, then the description, and a read more button, which points to the source of the news. So once I had a rudimentary wireframe in place, it was time to choose an appropriate GUI library. So I evaluated a few popular GUI libraries in Rust. There's one called Iced, which is a reactive library based on the Elm's model view update architecture. I'll leave a link if you want to know more on that. Then we have Druid, which by the looks of it feels like it builds a reactive layer on top of a retain mode API as it uses GTK underneath on Linux. Then we have eGUI, which is an immediate mode library inspired from the C++ image UI framework. We also have a recent one called 60 FPS, which is also a retain mode library, but it also gives you a declarative language to define your UI, which works similar to Qt Framework's QML language. So usually graphic libraries will fall into 2 categories, depending on what API they expose to handle the rendering of the scene or layout. The first one is retain mode API, and the other one is an immediate mode API. The major difference between the two is that the retain mode graphics builds and buffers an internal model of the widget layout and only renders changes as needed. Whereas in immediate mode graphics APIs, there's no such internal model of the scene being maintained, and the scene is rendered every frame, and that the client, aka the library user, controls the rendering of the scene. So I ended up choosing eGUI because I found the API to be very fluid and easy to use. In fact, I was able to get the first version of Headlines up and running in a day, which could have been even less if we factor out styling and an API config bug that I ran into. So big shout out to Emil for making such an intuitive and easy to use library. Apart from the GUI library, we'll also use a few additional crates. So there is confi, which will help us persist the API key and any state that we want to persist across restarts. Then there is tracing, which we'll use for logging information from the app. Then there is Serde, which will help us serialize data structures for confi, and the news API crate, which we built before, and that will help us make an HTTP request to fetch the news articles. So with the library selection and wireframing done, I created a brand new cargo project, and this time I'm using the workspace feature of cargo, which lets you manage multiple local crates in a directory. So in this manifest file, we have defined a workspace section, and in the members field, we have defined the local crates we want cargo to manage. So there's our news API crate from the previous episode and the headlines crate, which we have created as a binary crate. In the cargo.toml of headlines crate, I've added eframe as a dependency, which is a crate eGUI exposes as a top level library to make building applications easier. It simply re-exports type definitions from sibling crates such as API, eGUI, and friends. So within main.rs, let's remove the hello world print line. Now, before we write code, let's briefly go over an overview of GUI libraries. So the general interface exposed by graphic libraries is such that you first have to create a top-level window object. With the window object created, one can then add widgets into that. The widgets usually are of two kinds: container widgets and UI widgets. Container widgets, as the name suggests, are widgets that can contain other widgets, and they're usually used for aligning and orienting the child widgets contained within it. And UI widgets are basically widgets that contains some state and have a visual representation on screen. So this would be like a text label or a button. And then you also have an event handling loop, which handles inputs and interactions by the user. The event loop might also update the internal state of the widgets. Finally, there is a render API, which renders the state and layout of widgets by calling the underlying graphics API, such as OpenGL. Now, this was a very abridged overview, but you get the idea. So let's start writing some code. As mentioned before, we need to create a top-level window object, and eframe provides a function called runNative that creates a window. And this function takes in two params. The first one is an app instance, and this is going to be a box of dyn app. An app is a trait from the API crate, and the app trait has a bunch of methods that gets called at different states during the life cycle of the app. So we're going to have to create a type definition and have to implement the app trait on it. So I'm going to define a struct called headlines. Let's keep it a unit struct as of now. And I'm going to implement the app trait for headlines. And if I save this, I'm going to get an error, and it says that not all trait items have been implemented. So I'm going to use Rust Analyzer to quickly fill in the method for us. So as you can see, at minimum, we need to implement the update method and the name method. The name method is simply going to be the name of our app, and the update method is where all the magic happens. So within the update method, we can add widgets and also react to any state updates that happen within the app. And to start things with, we'll need to define a container widget. So eGUI provides us with a few container widgets. And to start things with, we're going to use the central panel widget. And if you take a look at the API, is that widgets are usually initialized with either a default or a new method. And then you have the show method, which actually renders the app to the screen. And the show method gets passed two parameters. The first is a context object that we will pass from the update method. And the second is a closure, which takes in a UI object as a parameter. And using the UI object, we can then add child widgets within the container widget. And as we go further, you will notice that it's a repeating pattern in the eGUI library that almost all of the container widgets have this sort of API. So let's go back to our editor. Let's define the central panel widget. I'm going to initialize it with default, and then I'm going to call show. And we already have the context object. And for this, we'll create a closure. And closures in Rust are created using double vertical bars. Between the bars, you can add parameters. This closure only takes in a single parameter, which is a UI instance. UI is a handle for us to create widgets within another widget. So within the body, let's add our first basic widget to start with. We'll use label widget, and this takes in a string that will get shown on the app screen. So let's type a random text here for now. And then to fix the two errors we have, let's create a headlines instance. I'm going to call this app, and I'm going to initialize it by just using the name of the struct, since it is a unit struct. And this still won't work because we need to box it. And for the native options, let's create a window option object, and let's use the defaults and change this to window option, and we should be good to go. So I'm going to do cargo run, and there you go. We have our first widget on the app screen. So let's continue with that. Now, instead of rendering a dummy label widget, let's try to print a list of news articles. We'll use dummy data for now, since we aren't hitting the news API endpoint. So I'm going to initialize headlines with an articles field, and this is going to be a vector of something called news card data, and news card data is going to be another struct where we have the title field as a string, then the description and the URL. With this change, we'll get an error because headlines now needs the article field to be initialized. So instead of initializing it the manual way, let's define a method on headlines. So I'm going to create a new method, and this will return us a new instance of headlines. And for the articles field, let's initialize it with a dummy data, and we're going to create a dummy data from an iterator here. So let's define our iterator, and we'll use a range iterator for that. Let's define 20 news articles and map the elements of the iterator to a news card data instance. So for the title, we're going to put a dummy title here, same with the description, and for the URL as well. So what we have done here is we created a ranged iterator, and to do that we have to specify the lower bound and the upper bound of the iterator, and this returns us a lazily evaluated iterator, which we can then call the map method. And what map will do is it will run this closure for each element of the iterator and convert that into a news card instance. The argument that you see here is going to be the elements of the iterator. So for every call, A is going to be initialized with 0, 1, and so on. So we have the iterator initialized here. And since iterators in Rust are lazily evaluated, in order to evaluate them and produce the results out of it, we're going to pass it to the fromIter method of vector, which will consume the iterator and create a vector of news card data from it. So there is our new function defined. Let's use that to initialize the headlines instance here, and this should compile. So then let's go back to the central panel widget, and let's use the dummy list of articles to render the articles to the screen. And we can use the label again, and we can render the title, the URL, then the description. And we have a reference error here because the for loop is trying to own the article fields. So in order to fix that, we can use the ampersand, which will only give us a read access within the for loop. With that, we should be good to go. So let's run this again. And there you go. We have a list of dummy news articles being printed. But if you take a closer look, we're only rendering about 10 articles in the screen, and the rest of them are nowhere to be seen. They're still there. If you try to expand the window, we can see the remaining of them. But this is not the experience we want. Instead, we should be able to scroll the window and be able to access other articles as well. So in order to fix this, we're going to use a scrollable widget within central panel. So I'm going to create a scroll area widget, initialize it with auto-sized function, and there is again a similar show method on that where we'll pass the UI from the central panel widget, and as the closure we pass UI again, and within scroll area we will place the list of news articles. So with that change, we should be able to render articles. So as you can see, we now have scrollable list of news articles, which is an improvement. So let's make more changes. Let's expand the text size of the article and also set a predefined window size so that it looks close to the wireframe we designed before. So to set the window size, I'm going to modify the window options object and set the initial window size, and this is going to be an option type, so I'm going to wrap it with sum, and then create a vector that contains the x and y points as the number of pixels. So I'm going to define a QHD resolution of 540 by 960, and this is going to be floats, so I'm going to suffix it with dots. And there is an error about mutability, so let's add mute, and this should work. And for configuring the font size of the article, we'll use the setup method from the app trait, and Rust Analyzer has auto-generated the method for us. So I'm going to reformat this so that we can read it. We can ignore these as of now. We'll come to that later. So setup is another lifecycle method from the app trait, and this is a one-time call that happens during the initialization of an eGUI app. So as you can tell, we can use it to do any preloading or configuration of the app. So we're going to use it to configure the font. So let's define a configure font method on headlines. This isn't defined yet, so I'm going to generate the method on headlines using Rust Analyzer. And this won't have any return type, so I'm going to remove this. Let's remove the to-do as well. And within configure font, we'll need to do three things. First, we'll create a font definition object. Then we'll load up the font. Then set the size of different text styles. And finally, load the font using the context object. So this method will also receive a context object. So let's pass the context object. Let's remove the underscore because Rust treats underscored variables as something you can ignore. And let's fill in the type of the context object. And this is a reference to the context object. So we're going to prefix this with an ampersand. So first, let's create the font definition. We'll initialize with defaults, and the font definition instance has a font data member, which is simply a B-tree map. And using that, we can insert our own custom font that we want. So if you notice in the directory structure, I already have a font copied in the local directory. So I'm going to use that. I'm going to rename this font heat to Meslo LGS. That's the font name. And I'm going to use a type called cow, which is a copy on write data type. And this is required because of how the font data field has a requirement on the value of the map to be of cow type. Within the borrowed variant of cow, I'm going to include the data from the font file. And this resides in the parent directory. So let's load this up and this should work. Okay, so this needs a string. So let's convert that to a string. And this needs an import. So let's import that. And we don't have font def mutable. So let's make it mutable. And this step is also done. So let's remove that. So with the custom font defined, let's try to set different font sizes for different text styles. So we can use the family and size field, which is again a B-tree map, to insert the desired sizes for the built-in text style. The first one is going to be for the heading, and this will be for the proportional font family of 35 points. This is going to be a tuple, so let's wrap this in a tuple. And let's also set the text style for the body to be of size 20. And then since eGUI comes with built-in font styles, we're going to have to tell eGUI to give priority to our custom font. And in order to do that, we'll need to insert our custom font at the front. So let's do that. So I'm going to use the font def instance again. And in the fonts for family field, we're going to get mutable access to it. And for the proportional font family, we're going to insert our font to the front. And finally, using the context object, we can set the font by using the setFonts method and pass in the font def object. So with that change, we should see quite a bit of difference in how the app looks like. And hey, we now have bigger font sizes. So let's go ahead and add a bit more customizations. So I'm going to speed things up since we're just going to be adding a bit of style changes to the app, and this is probably going to take more time if I go through it step by step. So I'll see you on the other side. Okay, so let's take a look at the changes so far. We refactored the loop which renders the articles into a render news cards method. And this is where the bulk of our style changes happen. So for each article, we're adding a bit of room for our widgets to render. So we have added a padding of 5. And after that, we are rendering the title of the article with a symbol. And then we use the colored label function to render the title in white. We do the same thing for the description. This time we create a new label object because we want to do a bit more customization, such as setting the text style. So either you can use the label helper function, or you can create a new label instance using the new method and can then add the widget using the add method. And then we come to hyperlinks, where before rendering the hyperlink, we change the visuals of the hyperlink color to be the cyan color. and then add a bit of padding, and then within a new layout area that aligns items from right to left, we then add our hyperlink within that. And then there is a padding at the end and a little horizontal separator so we can distinguish each news card from the other. So with those changes, our app looks something like this, which is already looking pretty good so far. The next, we'll try to add the header, the top header for the app, and also a footer, which will contain a few metadata or headlines. But before we do that, let's move the headlines definition and the impl block into its own modules so we can keep the main RS file clean. So I'm going to create a new module called headlines, and then we will move the struct and the impl block in headlines. To help Rust recognize the headlines module, I'm going to declare it with mod headlines, and let's also move the news card data. And we have a few errors, so I'm going to quickly fix these. So the errors were mostly about import issues and not having the pub keyword for the exposed modules. So now that we have headlines extracted into its own module, let's go back to main and let's create two helper functions. The first one is going to be render footer, and this is going to take a mutable reference to the UI. And let's also create the render header function, and it takes the same UI. Let's import that. So for the header, we are going to first add the top level headlines label. And for this, we're going to use a container widget called vertical centered. And this takes in a closure. And we'll add a heading widget. And for the contents, let's put headlines. Then we'll add a bit of space and use the same padding amount. And then let's also add a separator with custom spacing. We'll use 20 points as the distance, and we'll add it using the add method. So with that finished, we're going to call this right before the scroll container widget, and let's try to run and see how it looks like. So there we have our header, and let's now add the footer widget. So for the render footer function, we'll use the top bottom panel container widget, and we'll use the bottom variant. We'll give it an ID of footer and then call the show method. And this takes in a context object. So let's pass the context object. And the second param is again the closure, which gets the UI handle. So then we'll use the UI handle to render a vertically centered widget. And this again takes in a closure. And within that, we'll first add a space of 10 points. And for showing a bit of context or metadata about the headlines app, we're going to add three things. First, we'll add the API source website info. Then we'll add a link to the GUI framework. Then we'll put the GitHub link to the headlines source code. So for the first one, let's add a label. Let's use the monospace text style. For the GUI framework link, let's add a hyperlink. And for the text of the URL, we'll put made with GUI. And let's also use the monospace text style. For the GitHub repository link, we'll do the same thing. And then let's add a bit of space at the bottom. So there is our render footer widget. So let's call this function right below the scroll container widget. And we don't need this UI to be passed from the parent container, since we're going to have access to the UI handle here. So I'm going to remove that, and let's try to run this. So there you go. We now have the footer being rendered as well. So next, the final piece of the UI that we have to add is the top panel of the app, which contains the control buttons. So let's add that. So to render the top panel with the controls, we're going to render it right above the central panel widget. So I'm going to call self.render top panel. And this is going to be a method on the headlines struct. So I'm going to generate the method here, and let's remove the to-do here. So within this method, we'll first define a top bottom panel widget, and inside that we'll add a menu bar. Then we'll use two layout widgets to render the logo on the left and the control buttons on the right. And there will be padding before and after the panel. So let's start with the top bottom panel, and we'll use the top variant this time. Let's call it top panel for the ID, and let's call this show method. This gets the context object again, so we will pass the context object, and within the closure we'll then use the eGUI menu bar widget. This takes in the UI handle and again a closure, and within the closure we will then add a layout, and this layout is going to be from left to right. And for the contents of the layout, we'll add the logo of the app as a label. Let's use this, and let's keep the text style to be of heading. So this is going to be our logo, and then below that we'll create a new layout for the controls. We'll do UI with layout, create a layout, and this time it is going to be from right to left. And within the closure, let's first add a close button. So I'm going to do UI.add button.new, and let's use the cross symbol. We're going to use the text style of body, and you'll notice that we're capturing the result of adding the widget to the UI as the close button variable, and this is because we'll use it later to add event handlers to this button, so that if you click the close button, the app should then close. So next, let's define a refresh button. We'll do the same thing, and for the third button, let's add a theme button, and let's fix those errors. So with the control buttons and the logo added, we're done with the top panel widget. Let's go ahead and take it for a spin. We'll pass in the context object here, and let's run this again. And hey, we now have our control buttons and the logo on the left. Now it feels a bit crammed, so let's add a bit of space at the top and the bottom. So let's go back to headlines, and right before the menu bar, we'll add a bit of space, and let's use 10 points, and also at the bottom. And let's run this again. So there you go, we have a little bit of breathing room for the widgets. So with the changes so far, we are pretty much done with the static front-end UI for headlines, and I'm gonna call it a day as the video is probably going too long. So in part B of this episode, we'll be making headlines dynamic and make changes to fetch real data from the News API crate, and add a few more non-functional but nice to have changes. So in the process, we'll learn how to use Rust threads, channels within the context of an immediate mode API, which has its own challenges. So thank you for staying with me this far, and I'll see you in the next one.